Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual Camp Discovery, brought to you by Citrix, the museum's official innovation partner.
The heat is on as we create a colorful convection current to show how heat travels from hotter to colder places. Convection currents occur in our atmosphere frequently, driving ocean currents, affecting weather, as well as causing wind and thunderstorms.
Hi, welcome back to Mods. I'm Brady, and we're going to be talking about convection currents today. Now, convection currents basically means how temperature affects the way that air and water moves. It can be used for other things, but we're going to just think about the way that temperature affects our atmosphere and our oceans and how those interplay together. Now, if you've seen some of our other videos, you know that cold sinks and heat rises because cold is more dense. When there's cold water, those water molecules are bonded closely together, more so than the heat. And so you can fit more of the same water molecules in a tighter space if it's colder, and so that sinks to the bottom. Now, what we haven't talked about yet is how that influences the way that the ocean moves. Now, a lot of the weather and distribution of life on Earth is influenced by this conveyor belt that the ocean does that basically has cold water sinking from the poles and pushing water on its way to the equator out of the way, and then the rotation of the Earth gets involved, and now we have these swirling patterns. But we're going to take it back to just that initial reaction of cold water and hot water interacting together and pushing each other around. So how I'm going to demonstrate this is I have some hot water and cold water here. I have the hot water colored red because red is a warm color, and the blue is the cold water because blue is a cool color. All right, so I'm going to start with some cold water. And I'm just going to put it in my simulated ocean here, right? And the ocean has a lot of different shapes and stuff. We're going with a cylinder here. So I'm going to just tip this upside down and let it float. And we're going to watch where the blue goes, right? Now, the whole thing is kind of sinking to the bottom, right? Because cold water is going to sink. So the next thing I'm going to do is find our hot water. See what happens when I introduce some hot red water down here at the bottom. You can watch where that goes. So we can see that kind of coming up and rising and going to the top. And as these two things interact, you see the blue sinking down to the bottom, the red sinking down to the top. It's a kind of gradual progression of these things, and as the red goes to the top, it starts to push the blue down, and as the blue goes down, it starts to push the red up, creating this cycle. Now, when this happens on the ocean, the way that the ocean floor is formed, and the way that maybe other factors like the wind or just the general topography of the ocean floor or the rotation of the Earth also adds to it. But that basic reaction comes from this, right? We have hot water coming up, cold water going down. Now, you might be thinking, where is hot water coming from the bottom? There are a lot of geothermal vents on the bottom of the ocean floor, basically acting like these little water spout volcanoes, pushing a lot of heat up. So there's more than meets the eye. You might just think that the sun doesn't reach down there, it must not be hot. There's heat coming from all directions here on the globe. So this is our general pattern of how these convection currents work with this general experiment. And the same thing kind of happens in the air, in the atmosphere. And so I'm going to demonstrate that by taking a tea bag and turning it into basically a hot air balloon, because how these things work is when you trap heat, hot air, it's going to be less dense, so it's going to float above the cold, dense air. So to do this experiment, I'm just going to cut the top off of my tea bag here. That out, dump out the tea. Open up a little cylinder here. So now I have that cylinder, and I'm just going to light the top. And as this burns, I'm making the air inside this cylinder hotter, so it's going to be less dense, and when it gets light enough, it's going to float up. Because heat rises, cold sinks, and that can influence everything we know about the way the Earth works. So thank you for joining us, and we'll see you again next time.
Thank you for joining us for this episode of Virtual Camp Discovery. Special thanks to Citrix, Mod's official innovation partner, for powering this series. Please stay safe and connected with Mods by visiting our social channels at MODSFTL.